All right, today we are going to start factoring. So it's going to start off pretty easy. We're just going to factor trinomials with a leading coefficient of 1. We are going to spend a lot of time on factoring. We're just going to keep building on it so we can factor lots and lots of different types of polynomials. But before we get started on factoring, let's do a warm-up. For our warm-up, we are multiplying binomials together. So this was a topic that was on your quiz yesterday. When we multiply binomials, what should we think about? What two words? Double distribute. That's what we want to do here. Now, before, we were always writing out like x times x plus 5 plus 3 times x plus 5, right? Now, at this point, because we've done this and done this and done this, if you don't write that line, I'll just take it away, and instead you just draw your distributing arrows. So x times x, x times 5, 3 times x, 3 times 5. If you want to do that instead, that's fine. Now, be aware that if you do that incorrectly, I can't even try to give you partial credit. Okay, but if you're comfortable with double distributing now and you just draw those arrows, that's okay. So let's follow my arrows. X times x gives me x squared. X times 5 gives me, should I put a plus or a minus? Plus, it's a positive 5x. Okay, then we follow the arrows from the 3. 3 times x is plus or minus? Plus 3x, and 3 times 5? Plus 15. Good. All right, we still have one more step to get to our answer. We have to combine like terms. What gets combined? 5x and the 3x makes 8x. Oop, 15. So that is my answer. Are we not sure about the arrows? We want to go back to how we were doing it before? Or do we like the arrows? You like the arrows? Okay. So I start at x, and where would I draw an arrow to? The other x. And then I have to draw an arrow from x to what else? The minus 4. Where else do I start my arrows from? The negative 6 goes to x, and the negative 6 goes to negative 4. Okay. X times x. X squared. X times negative 4. Negative 4x. We're going to be going to the sticks pretty soon here. I've got like 2 voices I keep hearing. Negative 6 times x. Negative 6x. And negative 6 times negative 4 is a positive 24. Next step. Combine. What gets combined? Okay, those middle terms combine to give me negative 10x. And what, I kind of skipped over this last time. What else do I need as part of my answer? The x squared in the front, the plus 24 in the back. Questions about those multiplying binomials? It's something we practiced a lot, so I think that most people are okay with that. Anytime you see 2 sets of parentheses next to each other, that's what we're going to do. Before we move on to the notes, there's one other thing I wanted to just do a friendly reminder about. And that is, what does it mean to factor? What did I say that meant for us? we're going to factor something, we are going to write it as, you're close. You said times, which is what operation? Multiplication. To factor means we are going to write whatever it is, write it as a multiplication problem. Multiplication problem. So anytime you see factor as your directions, your answer should involve multiplication somehow. Now, usually when we do factoring trinomials, we'll involve parentheses at some point, much like the beginning problems did here. When we factor out a GCF, we usually only had one set of parentheses. When we factored a difference of two squares, how many sets of parentheses did we usually have? Two. Okay, when we factor trinomials, we will also frequently have two sets of parentheses. So if you want to put double parentheses after that, just to remind yourself that that's something we'll use, you can do that. Okay, let's go on to our notes. This procedure is for factoring trinomials whose quadratic coefficient is 1. So that means the factor on the x squared term. The quadratic means we're looking at the x squared term. The coefficient is 1 and the constant term is positive. How do we know what a constant term looks like? What does it not have? It's a constant. Okay, so just so we can figure out what it means to be a constant, I'm giving you the expression 3x plus 5. What do we usually call x? What is that? A variable. X is our variable. 3 is the coefficient on it. Okay, 3 is the coefficient on our variable. Does 5 have a variable? I should hear everybody answering that. Does 5 have a variable? No. That was not everyone, but it was better. 5 does not have a variable, so we call it a constant. 5 would be the constant in this case.
So a number without a variable is a constant.
A number without a variable is a constant. So if you want to make a note about that, no variable. Just a number. Number all on its own without a variable being multiplied to it is a constant. Questions about any of these terms? Quadratic, coefficient, or constant? Okay, so the coefficient or the number in front of the x squared term has to be a 1, and the constant term or the number without a variable has to be positive. That's the one specific situation that we're looking at today. So our rules, in case you have not already filled them in, so we are going to list the pairs of factors whose products equal the constant term. Now when we list pairs, this is a skill that we practiced, a skill that was on your quiz yesterday. What do we start with? 1 times whatever the number is. So in this case, that would be whatever the constant is. And then we check 2, then we check 3. So this is a step that we've done before, listing the pairs. We find the pairs of factors in that list whose sum equals the coefficient of the middle term. The middle term we usually refer to as b. We'll see this all written out in an example in just a minute. Okay, so we're going to list our pairs of factors for the constant term and figure out which one of those pairs is going to add up to the middle term's coefficient. All right, on our first example, they didn't use x, they used y. That's fine. Y squared plus 14y plus 40. So they've set up on your guided notes for you some tables to help us out with this. So that first table that they set up says we are looking for the factors of what? 40, because 40 is the constant. Factors of 40. And they kind of divided it so that you can list them out side by side. When we list pairs of factors, we start with 1 times 40. Then we would check 2 times 20. Should 3 go on my list? No. What about 4? 4 times? Should 5 go on there? 5 times?
7?
8. Okay. We check 6. Should it go up there? 7? 8? 8, yes, but it's already on there. So we don't have to write it again. We can stop looking. Okay, then that next column says that we are looking at the sum of those things. So I'll put a divider down here. Sum means what operation? Addition. If I add 1 and 40, what do I get? If I add 2 and 20, what do I get? If I add 4 and 10, what do I get? If I add 5 and 8, what do I get? 13. Okay. Which of those pairs of factors do you think I'm going to want in my answer? 4 and 10. So remember our directions from that previous slide said that we look for the factor pair whose sum adds up to the coefficient of the middle term. 14 is my middle term. So that's how I knew which pair I wanted. Do we have questions about this chart? Okay, let's also talk about that other chart that they put on there for you, which some people refer to it as the magic X. There's not really anything magic about it, but it's a way for us to organize our thoughts. Hopefully, you'll get good enough at these problems where you don't have to make this whole list every time. If you do, it's okay, all right, but this X kind of makes it go a little bit quicker. So on the X, the top of the X, we put our constant. So what should go in the top of my X? 40. At the bottom of the X, we put the coefficient from the middle term. That would be 14. So this is how we set it up if we were to just start the problem out. And then on the sides is where we fill in our numbers that multiply to the top. So if you want to put like a little times symbol by the top and a little plus symbol by the bottom, you can. You're looking for the two numbers that multiply to 40 and add up to 14. Now, we already found those. What are they? 4 and 10. Okay, so this is another way of organizing your thoughts about it as opposed to this bigger table. So you don't ever have to have both of these. You should have something that's kind of organizing your thoughts. This X way is a little bit quicker. Now, none of this has written our answer. On the very first slide, we talked a little bit about what factoring meant and what our answers looked like. What do you think I need to start building my answer?
See what you need to start building your answer.
Yep.
Something like y squared.
Kyan, what do you think?
To multiply.
We're going to be multiplying. So what symbol could I be using or symbols could I be using to show that I'm multiplying? Parentheses. How many sets of parentheses did I say we'll usually need on these? 2. Bless you. So we set up our two parentheses. Now remember, this is a multiplication problem. So if we kind of think backwards, think about our warm-ups, what would have to go in the front of both of these parentheses so that if I were to multiply them, I would end up with a y squared? Danielle is correct. We need a y in the front of both of them. A y times a y would give me a y squared when I multiply. Now, either one of these charts, the whole reason I went through it is to figure out what numbers go in the back of here. What two numbers are going to go in the back? 4 and 10, those numbers that we were trying to find. The 4 and the 10 were both positive, so we use plus signs in both of them. And this is my answer. So this is what I was headed for the whole time.
So we can all just use that?
Yes.
Why you just say you did?
Because I need you to know how to figure it out on your own when I'm not there to talk about it with you. Okay? So, either one of these is fine as far as showing your work goes. Either the X or the chart, whichever one you need. But your answer should be two binomials multiplied together. All right. On this one, we'll go ahead and fill in that table just because it shouldn't take very long to fill it in. If you want to just fill in the magic X, that's also fine. I'll do both. So first, we're looking for factors of what number? 7, which is our constant. What are my factors of 7? Anything else? No. And luckily, when I go to find my sum, 1 plus 7 is 8. Why is it important that the sum was 8? Because that's the middle term. That's what I need that sum to be. Again, if you filled in the X instead, what number should I have put on top? The constant, 7. That's what we're trying to multiply to. What number would go on the bottom? 8. That's what we're trying to add to. And my two numbers that would complete that would be 1 and 7. Okay, so filling out the chart on that one does not take very long for either of them. Then my answer, I don't have an answer up there yet. It should be written how? Beautiful. Use parentheses to show your multiplication. Y plus 1, y plus 7. Now, it does not matter to me if you wanted to put y plus 7 first and then y plus 1 in the back. That is also acceptable. You could write it y plus 7 times y plus 1. Multiplication is commutative. It means the same thing. What's different about number 3 from the first two problems? The middle term is negative. So this one's going to be just a little bit different. Our middle term is negative. So we'll have to think about this a little bit. We're still looking for factors of what? 18. Factors of 18. So let's start with that. Ryan, what's my first factor pair for 18? 1 and 18. Natalie, what's another factor pair for 18? 2 and 9. Jaquan, what's my other factor pair? 3 and 6. Any others? No. So then we look for their sums. All right, when I look for the sum of 1 and 18. Delaney, what do I get? 19. Jay-Sean, what do I get for the sum of 2 and 9? 11. And Jeriel, what do I get for the sum of 3 and 6? 9. Do any of these give me exactly what I want?
No.
No, but which one comes close? 2 and 9 comes close because they're sum was 11, but I need it to be negative. Jaquan, you got an idea? Make them both negative. If I were to take a negative times a negative, that would still give me a positive at the end, but it would make the sum negative, which is what I want. So if we were to fill in our x instead, the constant 18 goes on the top. That's what we're multiplying to. The middle coefficient goes at the bottom. That's what we're adding to. And on the sides, I would need a -2 and a -9. Does that make sense? Okay, they still both have the same sign. So who wants to raise their hand and tell me what to put in my parentheses? Jay Sean.
Plus and the minus?
No.
Just 2 minuses?
Would be 2 minuses. But can you give me the whole thing?
Oh.
Like my whole answer?
Y minus 2. Y minus 9.
Y minus 2.
You gotta multiply them together, then what is the positive?
2 variables, like the y times y?
No.
No.
-2 times -9.
Yep, -2 times -9 is a positive 18, which is why we have a plus 18 in the back of the original problem. Okay, does that make sense? Again, if you wanted to put y minus 9 in the front, y minus 2 in the back, that's fine. But we gotta have one of them as our answer. When you have these problems, like on homework, on quizzes, on tests, don't do all the work and show me all of this and then not write an answer down. Does that make sense? We did all the work to show me what your thought process was, but you also have to give me an answer. Factoring means we write it as a multiplication problem, so in the end, that's what we got to do. All right, we got one more with the charts already set up for us to do together. On this one, we set up our charts. We're looking for the factors of...
14.
Okay, I was going to say mine. 14 on this one. So, our factors of 14. Deja, can you give me one? 1 and 14. Tariana, can you give me another? 2 and 7. Anybody think of any others? 3's not going to work. 4 won't work. 5 won't work. 6 won't work. 7, we're back around to where we left off. So we'll look at the sum of them. May, what's the sum of 1 and 14? 15. Kion, what's the sum of 2 and 7? 15 and 9. Okay, what are we wanting a sum of? No.
10.
Close. -10. So if we're filling in that x, we're trying to multiply to 14. We're trying to add to -10. Do either of these give me something close?
No. Yeah. Close. No.
Close, but not close enough, right? Neither of these are a positive 10 or a -10. So there's nothing I can do that's going to make this work out for me. Do we see that? None of these numbers work. If that happens, then your answer should be that it is prime. It cannot be factored. That's considered a prime polynomial. You cannot factor it. There's nothing that's going to work out for us. I would not default to this. You are not frequently going to be given prime polynomials. So you better make sure that you exhausted all possibilities before you decide to tell me that something's prime. Does that make sense? Okay, so this is not something that will come up commonly. It's not going to be a frequent answer. So if you choose to put prime as your answer, you better make sure you show me that you checked everything out and nothing was going to work. All right. I'm going to give you a little bit of time to practice these. Notice that those big charts were not made, so if all you want to do is make the magic X, that's fine. Is that first problem one that you've already done? Oh, it is. How nice of them. Oh, it's different on your sheet than it is on the board. Okay. So I'll have to change them on the board when we get to them to match what yours is. But they're printed on your sheet for you. So you can practice those. If you just want to fill in the X and not make the whole table, you don't have to. And we'll talk about some of these in just a minute. Remember, your answers should be written in sets of parentheses. All right, on these, I'm just going to set up the magic X. I don't know why they call it magic. Personally, I don't think it's very magical. So if you made a table so that you could figure out what your numbers are, that's fine. If you had to look at all your factor pairs. But I'm just going to stick with the X for these. To set them up, Danielle, can you tell me what should go on the top and the bottom of my X on this first one? Good. We're multiplying to 6. That's on top. We're adding up to 5. That goes on bottom. Jalen, can you tell me what numbers should go on the sides to fill this in?
2 and 3.
2 and 3. Good. 2 times 3 gives me 6. 2 plus 3 gives me the 5. So then my last thing to do is just write my answer. Ellie, can you tell me what should go in these parentheses?
X plus 2, plus 3.
Good. X plus 2. X plus 3. And that is my answer. We get that first one right? All on our own. So proud. Okay, the next one is similar. We got similar numbers, just a little bit different. Jamal Dixon, can you set up the X for me? What should go in the top and the bottom?
Which number we on?
Number 2.
-6.
Good. 5 in the top. -6 in the bottom. Sorry, I almost said denominator. So we are multiplying to a positive 5. We are adding to a positive 6. Sorry, a -6. Make sure you use the sign from the middle. Okay. Let's see. Nevaeh, did you come up with the numbers that we should use?
I put -1 and -5.
-1 and -5 would be perfect. We need to have the same sign if we're going to multiply to a positive number. And they're both going to be negative if we have to add up to a negative number. So -1 and -5 is wonderful. Keon, can you tell me what should go in my parentheses? Okay, I agree, but I'm going to just write it. I'll use a Z, so that's what's on the board. So instead of putting plus a negative, I'm just going to put minus. If you used X instead of Z, that's fine. And then what about in the second set of parentheses, Keon? Okay, so I'm using Z's. Instead of plus a negative, just write minus. Technically, it's the same thing, but we need to clean up our signs. Questions, concerns? All right, on our next one. Lexi, can you help me set up my X?
18 on the top, 4 on the bottom.
Perfect. They're both positive. We are multiplying to 18, adding to 11. Jamarl, did you find the 2 numbers I need? Which ones? Yep, we're on number 3. Perfect. 2 and 9 are going to multiply to 18 and add up to 11. Ooh. Jakeem, can you tell me how I write my answer then? We'll need a 2 in there somewhere. The front of both of my parentheses should be whatever it's going to take to multiply to a u squared. So what times itself would give me a u squared? U. So we use our variable in the front, and then what about in the back, Jakeem? And I need to fill in both of them. So I got a 9, and I also use use the ones on the sides. The 2. And what sign should they have, Jakeem? Addition. They're both positive, so we put plus on both of them. Questions, concerns? We all paying attention? Great. All right, on number 4. Connie, can you help me set up my X?
28 on top, -11 on the middle.
Okay, 28 on top, -11 on bottom. We need those 2 numbers that are going to complete my X. Kelby, what do you think they are? Positives or negative? Good. -7 and -4 fill in my X. So then I can write my answer. Deshaun, how would I write that answer? Good. X minus 4 times X minus 7. Questions, concerns? Are we sure? Okay. On number 5, who wants to set up my whole entire X for me? Ellie?
7 on the top, -12 on the bottom, and -2 and then 10 on the sides.
Beautiful. Okay, we're multiplying to positive 20, adding up to -12. The 2 numbers that do that are -2 and -10. So who can fill in my parentheses for me? Jay Sean?
We on S?
Yep.
S minus 2.
And?
S minus 2.
Beautiful. Okay, if we're using negative numbers, we use minus signs. Questions on 5? Okay, who's going to set up my X on number 6? Natalie, is that a hand raise? Okay.
24 on top, 25 on the bottom.
24 on top, 25 on bottom. What about the sides?
1 and 24.
1 and 24. Wonderful. Okay, we're multiplying to 24, adding up to 25. 1 and 24 is what's going to make that happen. Jeriel, did you want to tell me my answer?
Y plus what? Y plus 24.
Y plus 1 times y plus 24. They're both positive. There it is. Questions before we get to our homework assignment?
No man.
Okay then. Oh, it's not on there. All right, let me write it up on the board for you.